Have you ever stopped to think about the really simple things? I mean, really think about them. Today, we're going to pull back the curtain on a skill most of us use every single day without a second thought: comparing numbers. We're going to break down the hidden, kind of beautiful architecture of how our brains even learn to do this.
Okay, so picture this. You're at a bustling market in the UAE. You see a basket with 12 dates, and right next to it, another with 18 figs. Which one has more? You already know the answer, don't you?
Of course, it's the figs. That's the easy part. But that's not what's so fascinating here. The real secret, the really cool part, is the journey your brain took, probably years ago, to make that answer so instant, so automatic. That's what we're unpacking today.
So where does it all start? Well, it all begins by making numbers real, by taking them from just ideas in our heads and turning them into something we can actually see and touch.
See, before we can compare anything, we have to get what a number even is. So step one is to build them. We use physical things, like these little sticks that show tens and ones. All of a sudden, a number isn't just a symbol on a page anymore. It's a real collection of things. It has weight, it has substance.
So once we can literally see the numbers, the next move is to give them a home. We start arranging them in a line, in a sequence, creating this kind of mental map, where every single number has its own special spot. And this right here shows you just how powerful that mental map is. You can see that 12 comes before 18 on the number line. That visual placement just hardwires the concept right into our brains. Numbers that come first are less than. Numbers that come later, it's such a simple, powerful visual rule. Okay, so now that we've got the core idea down, we need a way to talk about it, efficiently. This is where we level up to the next layer of abstraction. We learn the code. Check this out. It's like a little evolution happening on the screen. On the left, you've got a whole sentence in plain English. On the right, you've got a math statement. They mean the exact same thing, but the one on the right is a universal shorthand. It's a piece of code that's way faster and way more efficient. And learning this new vocabulary is absolutely key. These little less than, greater than, and equal to symbols, they aren't just squiggles. They're the fundamental language of comparison in math, and they're understood all over the world. And just like that, we can come full circle, right back to our market problem. That whole sentence, 12 dates is less than 18 figs, gets translated into this super clean, elegant piece of code. We've gone from a real-world problem to an abstract, mathematical truth. Pretty cool, right? But let's be honest with ourselves. Learning is messy. It's not a straight line. Our brains are basically pattern-finding machines, always looking for shortcuts. And sometimes, those shortcuts lead us straight down the wrong path. I mean, take this rule, for example. It kind of seems logical at first, doesn't it? We're taught to look at the ones column, so hey, maybe the number with more ones is just the bigger number. It's a really tempting shortcut, but you know what? It's a trap. So let me introduce you to someone. Meet Tiny. Tiny is a learner, just like all of us. And he's found this more ones rule, and he's feeling pretty smart about it. But the question is his rule a reliable tool, or is it about to get him into some trouble? All right, let's put Tiny's rule to the test with 57 and 91. You can see it in the table. Tiny looks at the ones column. He sees a 7 and a 1. Well, 7 is bigger than 1, so his rule says 57 must be greater. But nope, big red X, it's wrong. And why? Because his rule completely ignores the most important part, the tens place. 9 tens is way, way bigger than 5 tens. So Tiny's rule was a bust. Let's bring in another learner. This is Tommy. And Tommy, well, he's got a different strategy, one that's a whole lot smarter. Tommy's method is to start with the biggest, most important piece of information first. When he's comparing 65 and 25, he doesn't get distracted by the ones place. He immediately looks at the tens. 6 tens versus 2 tens. Game over. He knows right away that 65 is greater. And that right there is the key insight. Place value is everything. So this whole process, right, from physically touching blocks to making mistakes like Tiny, and then finding solid strategies like Tommy, it's all a journey. It's the journey of building a true mathematical mind. Every journey starts with that first step. And in learning, that step is just trying. This is our trying turtle. It's all about being brave enough to just give it a shot, even if you're a little slow, a little clumsy at first. This is where you make mistakes, and that's not just okay, it's absolutely essential. Then you move into the next stage. You become the learning lizard. This is when you're in the thick of it. You're practicing. Things are starting to click. The patterns are making sense. Your strategies are getting better. You're not an expert yet,
but you're getting it. You're actively building up that understanding. And finally, you reach the goal, you become the confident camel. This is mastery. At this stage, you don't just know the answer, you understand why it's the answer. You can use the skill without even thinking about it, and you could probably turn around and explain it to someone else. That's when you really know you've got it. So let's end with this thought. We've just walked through this beautiful, structured process for learning a pretty simple skill. We go from concrete objects to abstract symbols, we go through trial and error, and then we achieve mastery. So if this is the blueprint for how we learn to compare 12 and 18, what does that tell us about how we learn to tackle the biggest, most complex problems we face in our world?